anything together. When you're adding and subtracting, that sum of them is one. All right, so for that first one, remember when it just wrote the next to each other like that, times it. So it was 10AB for the first question. The second one was -6. That was 1 mark, and then a to the power of 4 was another mark. Now guys, for this one, a few of you subtracted. So a few of you said 3a squared minus 2a squared. All right, but that's not subtraction there. If you have two brackets next to each other, you're timesing it. Okay. For the next one there, you have a negative times a negative times another negative. That is a negative. Then you have 4 times 3, which is 12, and then you have x cubed, y cubed. All right, so it was, I basically gave 1 mark for the negative 12 and 1 mark for the x cubed, y cubed. For number 4 there, it was x squared, y squared, z. Let me just add something here because the order is actually different than the one here. Okay, we'll get to that one now. The next one was just 1 mark, negative 21AB. Then the one after that, guys, a few of you changed this D to a B. Just be aware of that, that's D. Okay, you're not supposed to change that. I do understand that obviously D and a B, they look similar. All right, but this is a negative 2 times a negative 5 is positive 10. You have a times a, which is a squared, and then you have that Q there. For the next one, I wasn't really fussed about the order. All right, it's supposed to be alphabetical order, but what this question was more about was figuring out that you have a negative times a negative times a negative, which is a negative, and then just writing all of them next to each other. Okay, so that's what I gave a mark for there. So if you wrote them in any order, it's fine. I wasn't strict on that. Then for the next one, 2 goes there in front, and then you have x squared times x, which is x cubed, y to the 3 times y, which is y to the 4, z to the 4 times z, which is z to the 5. Oh, guys, I just want to go back up to 7 quickly. Quite a few of you also changed this just to minus p minus q minus n. So 3 separate terms. When you have brackets, you can't do that. Okay, when you have brackets written next to each other, that always means that you're multiplying them together. For the next one, most of you got the 8x part correct, but then you messed up with this y. So let's just take a look. It's y minus 2y. That's negative 1y. And then you minus another 3y. That is negative 4y. Okay, many of you have a plus 1y, or you had a minus 7y, or you had a different thing there. So I gave 1 mark for 8x and 1 mark for negative 4y. Okay, so if you got the 8x, you still got 1 out of 2 for that one. The next one, guys, many of you put the x squared and the x together. They are not like terms. You cannot add those. Right? What a couple of you actually did was you got this and then you said, okay, now let's just times x squared and x. I'm just deciding, I'm just going to times them together. It doesn't say that you're multiplying, all right? So if you have x cubed in your answer, then you decided to times things together that weren't supposed to be multiplied. Okay. So what you had to do here, it was actually just one addition that you had to do. Negative x squared plus 2x squared is a 1x squared. Y squared is not a like term, so you can't add that. And then plus x, also not. That's just in your answer. Okay, so you end up with 3 terms, which is possible, guys. A few of you did this correctly. All of these ones where you're supposed to add and subtract the like terms, and then in the end, you just multiplied everything together. That's wrong. Okay, you lose a mark. You have to leave your terms as separate terms. You can't just decide now I'm going to multiply things together because you want one term in your answer. Okay. For the next one, 2ab squared plus 3ab squared is 5ab squared. And guys, this is one where they're trying to trick you, right? ba squared. You see that this is in incorrect order. This is actually supposed to be 2a squared b, yes. In which case this and that one, those are like terms. So you can add those together. Negative a squared b plus 2a squared b is 1a squared b. All right, positive 1a squared b. So again, it was 1 mark for that first term, which most of you got, and then 1 mark for the last term. For the next one here, you have to do BODMAS, right? A times A you have to do first. That's A squared. And then A plus A is 2A. Now, this is another question where many of you got this and then you thought that doesn't look right. It's two terms. Let's times them together. Let's say, okay, that's 2A cubed. So guys, that's a plus, not a times. Okay, that's what I want you to learn from this. Because when they ask you to add, you just add. Okay, you don't change it to a time. The next one was similar, just collecting like terms. So it was 3A plus 3A is 6A, 1 mark for that. And then 4B minus 1B is 3B, 1 mark for that. For the next one, we times it, right? So 4 times 4 is 16, and 8 to the 4 times 8 to the 5 is 8 to the 9. It was 1 mark for that. And here you're just adding them together. Most of you got this one right. 4A to the 4 plus 4A to the 4 is 8A to the 4. The next one was another like terms question. So 4A squared plus 5A squared is 9A squared, 1 mark for that. And then you're looking at all these A's that we have to simplify. Okay, so 3A minus 1A is 2A. And then you add 6A to that. So 2A plus 6A is 8A. And like this one, most of you didn't get this one, right? Most of you said, lovely, 2 plus 2 is 4. But can I do that, guys? What does BODMAS say? You must first multiply, hey? And even before we multiply, we need to simplify this bracket. Now, do I have like terms in this bracket? If it's an x, y, and a y, x. Those are like terms, right? The one order is just wrong. So 3xy plus 2xy actually is 5xy. So before you could times in, you have to simplify that bracket. And guys, we did an example like this just before you did the test, right? Where you have a bracket that you can actually simplify first. Okay, so that was the first thing. One of those marks went to that. Minus 4 times x times y, guys, that's just 4xy. Many of you put all of this together and decided to times by 5 as well. But that's not a times 5, that's a plus 5. Okay, so I'm just pointing out, I'm not trying to embarrass anyone, I'm just pointing out mistakes so that we can fix it. Okay? So this is one term. Remember what we do earlier the year? We circled all our pluses and minuses. Right? You can still keep doing that, guys. You gotta make it easier. So the 2 is on its own. 2 times this bracket you simplify. Plus this you must simplify. 4 times x times y is 4xy. That was the second half. And then plus 5. Then in my next line, the only thing that I did, right? What does it mean when you have a number in front of the bracket? You are timesing, right? And what is 2 times 5? 10. That was the third one. Okay, so doing 2 times 5xy, we're getting 10xy. Then the final one was now all of our terms are now simplified. So now we can add it to that. Okay, so here 2 plus 5 is 7. And 10xy plus 4xy is 14xy. That was the last one. So actually adding and subtracting. Okay, so I don't think it went too badly in general. If you're not talking about that, you need to figure out where you went wrong. Okay, because often, I mean, these questions were all testing the same thing. They were testing addition and they were testing multiplication. Or addition, subtraction, and multiplication. So if you got the multiplication wrong in one question, you probably got it wrong in all of the questions. Okay, so if you got maybe like a 10 out of 50, it doesn't mean that you can't do anything. Maybe you just made the same mistake a bunch of times. Okay, so you need to figure out what that mistake is and what you must actually do. So feel free to come to me at the end of the lesson when I give you guys work to do. If you're not sure where you went wrong, I can always help you with that. Okay. Guys, we're going to keep doing class tests, especially with algebra, because we're going to keep adding topics, and I don't want you guys to get confused, all right, because there appears to already be a little bit of confusion between addition and multiplication. All right, so it's on the board here, guys. We add, change the number, right? Sometimes we change the exponent. Okay, we need to keep remembering that. All right, we are doing division today, finally. All right, so you can start a new page. If you want to, you can stick your test into your book quickly. so that you have that. But we are starting division of algebraic expressions. I'm going to do some numerical examples just to start off with, and then we're going to bring that into algebraic examples. That's the first one. Give you guys a chance to catch up. So guys, do we all remember that instead of writing something with a division symbol, we can actually write it as a fraction, right? So instead of writing 2 to the 5 divided by 2 to the 3, we can write 2 to the 5 over 2 to the 3, right? That fraction line means division, okay? And these questions are going to be much easier if we actually do that. If we just always write it as a fraction, usually it will be given as a fraction, okay? But if they use the division symbol, you can always write that as a fraction. Now guys, in order to show you what happens here, we are actually going to expand the numerator, the number at the top, and the number at the bottom, the denominator. 2 to the power of 5, that's 5 2's, right? Multiplied together. Do we agree with that? So I'm going to write 1, 2, 3, 4, 5 of them, right? You're not going to have to do this every single time, guys. We're just doing it for now so that I can show you the pattern. All right, over 2 to the power of 3, that's 3 2's, right? If we understand that exponent notation, anything to the power of 3 is just 3 of the same thing being multiplied together. Now guys, what we're going to do now is we are going to take the first 2 at the top, and I'm going to remember, what does this line mean? It means I'm dividing. I'm going to take the first 2 at the top and divide it by the first 2 at the bottom. What is 2 divided by 2? 1, okay? So if I say 2 divided by 2, I'm going to be left with 1. You can actually draw a thin line through both of those, right? When we do that, 2 divided by 2 is 1. We are then going to do the same thing with the second 2 at the top and the second 2 at the bottom. What is 2 divided by 2 again? 1. So let's just draw a line through each of them. When I do that division, I'm also left with 1 here. Now guys, I have 1 more 2 at the bottom, right? So I can do it with the third 2 at the top and the last 2 at the bottom. Again, 2 divided by 2 is 1. You guys see that I have cancelled out all of the 2's at the bottom. What am I left with? 2 2's at the top. How can I write that? 2 times 2 is the same as 2 to the power of 2, 2 squared. And guys, because that's a number, we know what it is. Hey, what's 2 squared? 4. So that is the answer. So we're going to use this method whenever we are dividing. All right? You expand what is at the top. You don't have to physically do it. You can just kind of imagine that, visualize that as well. But we will do it in class just until you guys get the hang of it. Then whatever you have at the top and the bottom, you can divide. So if you have a 2 at the top and a 2 at the bottom, you divide those 2's. 2 divided by itself is 1. That 2 divided by that 2 is again 1. That 2 divided by that 2 again is 1. As we have been doing cancelling out, hey, cross-cancelling with fractions before. That's almost what we're doing here. We're almost cancelling out the first 2 and the first 2. All right, because when I say 2 divided by 2, I'm left with 1. Whatever is left at the end, that is your answer. Okay, 2 squared, which is 4. Right, let's do another one. We're just going to practice a whole bunch of them. So number 2, the second one is, let's do a to the 6 divided by a to the power of 2. So now we're not working with numbers, we're now working with variables, all right? But we're going to use the same method, guys. So instead of using the division symbol, it's better if you write it as a fraction. Yes, no? Okay, so a to the 6 over a to the 2. About a to the 6, that's just 6 a's. Right, so let's do that. 1, 2, 3, 4, 5, 6. I know it's a lot of writing, but we're not going to have to do this all the time, guys. I'm going to show you the shortcut in a little while. At the bottom, we have a squared, which is a times a. We're going to take the first a at the top and divide it by the first a at the bottom. What is a divided by a? 1. You can write that 1 there, guys. You actually don't have to. All right, but if it makes sense to you, then that's okay. We have another a at the bottom, so we can do it again. The second a at the top divided by the second a at the bottom. Again, a divided by a is 1. Do I have another a at the bottom to cancel out? No. So what's left at the top, guys? 1, 2, 3, 4 a's. How do I write that? A to the power of 4. Can I work that out? Like, is that equal to a number? Okay, no. If it was a 2 to the 4 or 3 to the 4, then yes. Okay, but if it's just a variable, that's your final answer. Okay, I'm going to do one more, and then we're going to see if we can generalize a rule here that can save us some time instead of writing them out every time, as we can come up with a pattern. Sorry, I'm just looking for like that. Okay, let's do 3 to the power of 3x to the power of 4 over, so I'm writing it as a fraction now from the start, but we remember that when something's written as a fraction, that means that you're dividing, over 3x squared. So 3 cubed x to the 4 over 3x squared. Okay, now guys, you need to remember that this means that you're going to divide. Okay, because now they haven't actually used the division symbol. So maybe just draw an arrow from that line, the fraction line. That means that you are going to divide. Okay, you have to remember that. They're not always going to use the division symbol. Right, so if they've given you a fraction, you need to know that you must now divide. So let's expand what we have at the top and the bottom and see what happens. 3 cubed is 3 threes, right? 1, 2, 3 of them. And guys, what am I doing again if I have a number written next to a variable? That's multiplication, right? If it's a 3 cubed next to an x to the 4, that means that I'm timesing these together. Okay, so I'm going to say times again. And now I have x to the 4, so that is 1, 2, 3, 4 x's. All being multiplied together. That is all over. At the bottom, it's a bit less writing. There's just 1 3. Okay, so 3. Again, the 3 is written right next to the x squared. That means I'm multiplying it. And x squared is x times x. Yeah. That's going to be 9. This is 1 3. Okay, guys, now we're going to take whatever we have at the top and the bottom. That's the same. And divide them. Okay, so I'm going to take the first 3 and divide it by the 3 at the bottom. What's 3 divided by 3? That is 1. Again, you don't actually have to write that one. Okay, it's enough to just draw the lines through. But you can write the 1 next one. Do I have another 3 at the bottom? No. So these 2 3s that are left are going to be in my answer. Okay, I can't divide a 3 by an x. Okay, so once you're done with the 3s at the bottom, you can't divide anymore. Let's look at the x's now. The first x divided by the first x at the bottom, that again is 1. Remember, anything divided by itself is 1. Okay, so x divided by x is 1. The same thing for the second x. That x divided by that x again is 1. Do I have anything left in the denominator now at the bottom of that fraction? No. All right, so I'm done. I'm left with 2 x's. Now we just need to write our answer, guys. What are we left with? 3 squared x squared. Right? 3 squared times x squared if you want. I'll write it like that at first. We're left with 3 squared times x squared. But guys, you can't leave our answer like that. What is 3 squared actually? 9. And when we time things, we don't write that times, right? We just write the number and the variable next to each other. Okay. So the answer there is 9x squared. Okay, now guys, let's just look at the example that we did and let's see if we can actually come up with a rule that will prevent us from having to write this out all the time. Because what if you have 26 x's at the top and 13 at the bottom? I don't want to do that, okay? That's going to take forever. So let's see if we can look at, or if we can find a rule. If we just look at the questions that we have. If we're looking at 2 to the 5, divided by 2 to the 3, and our answer is then 2 to the 2. If you see it, don't shout it out, guys. I want everyone, please, to get a chance to look for the pattern here. So I'm going to look at my exponents, okay? So let's look at that 5, and that 3, and that 2. Don't say it yet. We're going to look at all 3 of the examples before we discuss it. Okay, so just see if you can recognize the pattern there. Let's look at the next one. We have a to the 6 divided by a to the 2, and the answer was a to the 4. Okay, I'm sure it's becoming a bit clearer now. Let's look at the last one quickly. What was the exponent of 3 here? We didn't write anything, but 3 is actually 3 to the 1. Just put that 1 in there. Okay, if you have space, if not, don't stress. But that is going to make it a bit easier to see what the pattern is. Okay, so we have an exponent of 3 and an exponent of 1. And then in our answer, 3 then has an exponent of 2. And if we're looking at the x's, At the top, we have an exponent of 4. At the bottom, an exponent of 2. And then our answer also an exponent of 2. Okay. Aaron? Yes. Okay. So we're looking at the first exponent is 5. Divided by 2 to the 3. 5 minus 3, guys, is 2. What do we notice about the bases? Do we know what the base of the power is? Okay. Do we know that if you have an exponent, I'm just going to write it here. The power is like, wait, let me rather do an a to the x, right? If we have a power, oh, sorry, it's blue there. We have a power like that. The a, the number or the letter or whatever at the bottom, that is what we call the base. All right, that's quite important that you know that. We're going to talk about the base of an exponent quite a lot. So the base is that number at the bottom, and then obviously the x is the exponent. So just make sure that you know that terminology, guys. So just write it down somewhere. So I want us to look at the bases, right, from the ones that have the exponent. So I'm looking at, because we recognize that we're minusing 3 from 5. We're saying 5 minus 3, right? And that's getting us 2. What happens to the bases though, guys? I'm starting with a base of 2 here. I'm dividing it by a base of 2 there. And my answer, before I actually work it out, also has a base of 2. You see that? 2 and 2 and 2. Right? So let's just underline that. That 2 divided by that 2 gives me a base of 2 again. So hopefully you have space next to this question so that we can just write it in a slightly different way. When you are saying 2 to the 5 divided by 2 to the 3, instead of writing 5 2's and 3 2's and then cancelling them out and then writing your answer, you can actually say that this is 2. Remember, we keep the base the same, right? We saw that there. 2 and 2 and then 2 of the first exponent minus the second exponent. We can do it like that instead. Okay, that's going to save you a lot of time. And what is 5 minus 3? 2. Now, if that's a number, guys, 2 squared is equal to 4. All right. So you first minus the exponents, but it's very important that when you minus the exponents, your base must be the same as the bases in the question. Okay, so you're starting with bases of 2. The base in your answer is going to be 2 as well. Okay, we'll do some more examples now so you can see that more clearly. We're looking at the next one. It's the same thing, right? A to the 6 divided by a to the 2. So we can write it differently. If you have a to the 6 divided by a to the 2, what bases did I start with? A. So my answer has a base of a. We take the first exponent minus the second exponent. 6 minus 2, which is what? 4. That is the answer. Yes. Okay, any questions at this point, guys? We're going to do the third one now as well. Waiting for everyone to copy that down. Now for the third one, there were actually 2 different bases, right? There was a base of 3 and there was a base of x. But we're going to do the same thing for both bases. All right. And we're down here. All right. For this one here, I'm just going to write it at the bottom here. 3 to the 3, x to the 4 over 3 to the 1, x to the 2. Right, that was the question there. Guys, we have to do the same bases together. Okay, so we're going to look at the 3's. We have a base of 3 and a base of 3. So my answer has to have that same base I'm going to take the top exponent, the first exponent, the one at the top, minus the one that I'm dividing by, minus the one at the bottom, so minus 1. Then I'm going to do the same thing for the x's. An x at the top and x at the bottom, my base has to stay the same. I'm going to take the first exponent, the exponent at the top, minus the exponent at the bottom, the one that I'm dividing by. Okay, now we're just going to do that subtraction. 3 to the power of 3 minus 1, we all know that that is 2, right? And then x to the power of 4 minus 2, that is also 2. Now all that's left for us to do is just to write 3 squared as 9. Okay, if it's an actual number, guys, you have to write that number, please. You can't leave that as 3 squared. Okay, guys, you can decide which method you want to use. If you want to do the expansion and do the physical cancelling out, be my guest, you're more than welcome to do that. Okay, if that is the method that makes sense to you, that's fine. Yeah. So we did now, but no, you can't. You can't use this rule. Okay, so guys, this rule of where you take the top exponent minus the bottom exponent, you can only use it if you have the same base. All right. So what Ryan is asking is if, for example, let's do a number 4 here. If you have a 5 to the 3 over a 2 squared. Now maybe you're not sure. Can I take the top exponent minus the bottom exponent? I don't guess. All right. If you don't know if you can use the second method for it, use the first method. Let's do the expansion there. What is 5 cubed? 5 times 5 times 5. Right? That's 5 cubed. Over, what's 2 squared? 2 times 2. Can I cancel out a 5 and a 2? No. So we can't do that. All right, we can't use that method. Now we're going to actually have to work this out. We're working with numbers, right? We can actually do this. I believe in you guys. 5 times 5 times 5. Do we know what that is? 125. Over 2 times 2 is 4. Guys, that fraction actually can't be simplified. So that's the answer. Right? For the second method, when you take the top exponent, I'll write it down now. When you take the top exponent minus the bottom exponent, you can only do that if you have the same base. If you don't have the same basis, you're going to have to work it out some other way. But guys, to be honest, they won't give you a question like this. All right, this is almost a bit silly. Like, you can't use the rule. Okay, so let's just quickly make a note here. Therefore, our conclusion that we are making after doing all of these examples. If you have, I'm going to write it in general terms, all right? So I'm going to use letters to write down this rule. If you have a to the power of m, so a base to the power of an exponent, and you divide that by the same base, so a again, with a different exponent, your answer is then going to have the same base, and you're going to take the first exponent minus the second one. Let's make a note because it is very important. It's the key to actually being able to use this rule. You have to have the same basis. You can only do this if the bases are the same. All right, so can only use this rule if the bases are the same. Okay, that is what you're going to practice now, guys. So I'm just going to put a worksheet on the board for you. Actually, sorry, I'm going to do a few more examples. I can't actually give you this worksheet yet, sorry. Okay, are we fine? Are we putting this down? All right, now guys, what I want you to notice is that in all of these examples, we always have one term that we're dividing by one term. All right, I'm just going to show you quickly. We're going to go up. 2 to the 5, that's one term. Divided by 2 to the 3, that's one term. All right? It's the same with all the others. One term divided by one term. Again, one term divided by one term. This is one term, guys, but it has two parts to the term. All right, remember what separates terms again? Pluses and minuses. All right. Times, which is what we're doing here. We're saying 3 cubed times x to the 4. That does not separate them. So this is one term. All right. Same thing in this last example. Also one term divided by one term, even though we didn't use that rule. Now, sometimes they're going to give you more than one term at the top of the fraction that you must then divide by something. Okay, so let's do a few examples like that quickly. So that will be example 5. Let me just see quickly if I can find some nice examples here. Oh, sorry. For example, okay, I'll just make up some examples here. All right, we are doing 3x squared plus x cubed y, and that is now divided by x. Now guys, this example is different from the previous one because now we have two terms at the top. All right, so I want us just to make a note of that. We have two terms. We remember that pluses and minuses separate terms. So because there's a plus there, those are two terms that we're working on. Now guys, whenever you have two terms, right, at the top, and in grade 8, you won't have more than one at the bottom. Okay, in grade 8, there will always only be one at the bottom. So don't worry about what happens when there's more than one. Okay, we'll do that next year. When you have more than one term at the top and one term at the bottom, you are going to split the fraction up. This is right there, therefore, split. Actually, the numerator we're going to split up. So split numerator up. And this is what you are always going to do for these types of examples, guys. You are going to take each term in the numerator and write them over that denominator. So I'm going to take 3x squared over x plus x cubed y over x. So I'm taking one fraction and I'm splitting it up into two separate fractions. Guys, remember when we worked with fractions last term? You remember that if you have multiple fractions, let's say two fractions, and they have the same denominator, you can put those two fractions together as one. You remember that? We did that when we were adding and subtracting fractions. If you have the same denominator, we used to have to find the LCM and then put them together, right? But if I gave you this as a question and I said simplified, you would say, oh, nice, we have the same denominator. I can put these two together as one fraction. Now we're going the other way around. Okay, now I've given you one fraction. And in order to simplify this, in order to actually divide this, you need to split it up into the separate terms all over the same denominator. Okay, so that's what you're always going to have to do. And guys, now we're going to calculate each one separately. So let's see if we can use that rule. There's a 3 at the top here. Is there a 3 at the bottom? No. So what do you think is going to happen to that 3? It must say, hey, it's going to be in your answer. Okay, so 3 is definitely going to be in my answer. There's no 3 at the bottom that can cancel it out, that I can divide one. I have an x squared over x to the 1. We agree that there's a 1 there. You can put that 1 there if you want. And I'm dividing, so I'm going to keep the same base. I'm going to take the top exponent minus the bottom exponent. Okay, we're done with the first one. Plus x cubed y over x. Now guys, there's an x at the top and an x at the bottom, right? So x cubed, so x to the 3 minus, remember when we divide, we minus the exponent. Again, what is the exponent of the x here at the bottom? 1. So when I minus, I'm going to minus 1. Okay, the top exponent minus the bottom one. So 3 minus 1. And what about that y? No? Is there a y in the bottom? So can I throw away that y? Or must it be in my answer? It must be in the answer. Yes, Jaden, you have a question?
No, I don't understand. If it's 1x, how can you put all the other x's and minus by 1? That's
So we've split this fraction up into 2 separate fractions that when I add together will give me that.
but in both those fractions there, 1x is even like 1 squared is 2x on the left.
Remember when we did fractions, right? If they had the same denominator. So if you're looking at that blue there at the top, then you could put them together over that same denominator. You don't add the 2 denominators together as well. Okay, remember when we did addition and subtraction. So if you had like a 1 over 2 plus a 3 over 2, because they have the same denominators, you could put it all together over 2, you keep the denominator the same, and then you do 1 plus 3, which is 4. Okay, so it's the same concept here. Just instead of a 2, we now have an 8. Okay. But essentially what this question is asking us to do is it's asking us to divide everything at the top by x. Right? This line, this fraction line means I'm dividing whatever is at the top by what is at the bottom. Now, because I have 2 terms at the top, I have to divide both of those terms by x. Right? That's what this question is saying. It's saying both of these terms must be divided by x. So when I split it up into 2 fractions, that is what I'm doing. Okay, does that make more sense? All right. Now, guys, we just need to simplify this. We have a 3 x to the, what's 2 minus 1? 1. Do we have to write that 1 as an exponent? No. Okay, so we can leave that as 3x plus x. Now, what's 3 minus 1? 2. And then that's y. Okay, so that is the final answer. Again, guys, it's saying adding. So I'm not going to now change this plus to a time so that I can put them all together. That is the final answer. Okay, they're not like terms, so I can't add them together. Okay, I'm going to do one more just so that you are all sure of what's going on here. So number 6. How many terms do I have at the top now? 2 again, right? Because of that minus there. Okay, so 2 terms. I'm just going to write it again because it is important. 2 terms. So therefore, split up. Split fraction up. Okay, but I'm just going to write split up. You guys know what that means by now. So we're going to take each term separately over that denominator. I'm going to take 8x squared y cubed, which is the first term, over 2xy. And there's a minus in between those two terms. So you have to put a minus in between your fractions. That's quite important, right? In the previous example, there was a plus in between the terms. So we put a plus in between the brackets or the fractions. So maybe just circle that plus there as well, so that we know where that sign is coming from. If there's a minus in between the terms, you have to put a minus in between the fractions. Now we're going to take the second term, which is 2xy squared over 2xy. Yeah. Now guys, this one is slightly different because if we're looking at the numbers, right, there are no exponents that we're working with there. So we just see that that's an 8 and that's a 2. We all know how to divide 8 by 2. Right? What's 8 divided by 2? 4. So guys, remember when we were doing the multiplication stuff, if it was a 2 times 3, you still multiply them together like you normally would. Okay, we can still work with numbers, even though we're also working with letters and exponents and stuff. Okay, if it's just saying 8 divided by 2, we all know that that's 4. All right, so if it's just a number divided by another number, we can still do that like we normally would. Let's look at the x's. There is an x at the top and at the bottom. We're dividing. So I'm going to take the exponent of x at the top, which is 2. I'm going to minus the exponent of x at the bottom, which is what? 1. Again, you can put that 1 there if you want to. I have a y at the top and at the bottom, so I'm going to take y. I'm going to take the exponent of y at the top minus the exponent of y at the bottom, which is also 1. We actually passed them when we typed. What we were doing before. All right, now let's look at this, guys. What's 2 divided by 2? 1. That's interesting. That's almost like a cancelling out thing. Hey, you have a 2 at the top and a 2 at the bottom. That's just 1. Doesn't the same thing happen with the x's? X divided by x, what's that? X divided by x, anything divided by itself. That's also 1, hey? But guys, if you did it using this rule, let me just show you what happens. X, what is the exponent of x at the top? 1. Minus, what's the exponent of x at the bottom? 1. We'll talk about that now when we actually simplify it. Okay, we're looking at the y's. At the top, we have an exponent of 2. So we minus the exponent of 1 at the bottom. So now we just need to simplify all of that. So we have a 4x, 2 minus 1 is just 1. Okay, we don't have to write that 1. For the y's, 3 minus 1 is 2. So that is what we get from our first fraction when we do that division. Minus. Now guys, we did say 2 divided by 2 is 1. Okay, that's why there's no number there, because the number would just be 1. But what's happening here now? I did mention it once, and then I said we're going to come back to it later, and now is later. All right, 1 minus 1 is what? 0. So this is actually x to the 0. Please, you guys remember I said anything to the power of 0 is 1. So let's just take a different color pen there. We'll put there that that is equal to 1. And guys, the reason for that is, what do we have to get? X divided by x. Anything divided by itself is 1. All right, so if you're just doing the normal division, you're just cancelling out the x and the x. You're getting 1. But if you're doing your exponent minus exponent rule, you're getting x to the 0. That has to be equal to 1, guys. Right, anything to the power of 0 is equal to 1. What do we get with our y's? 2 minus 1 is just 1. Now, unfortunately, I can't leave this x to the 0 in my answer. Okay, I need to remember that x to the 0 is 1. So I'm just going to write 4xy squared minus 1y, but remember we don't write that 1 if it's in front of the letter. So that last term is just minus y. Incorrect. You're going to spend a couple of days just practicing this. Okay, so if you're a bit confused now, you're going to practice a few of them, then we'll mark tomorrow, then you're going to practice again. Okay, so just try your best with this worksheet that I'm going to give you now. So guys, this worksheet is on Google Classroom already. It's this one that I posted a while ago, the algebra practice worksheet. I'll show you now where to find it. You are going to be doing question 4, which is division. You're not going to be doing all of them. I would like you to do 4.1 to 4.7. All right, so just write algebra practice worksheet 4.1 to 4.7. And that multiple term thing actually doesn't come up in those questions. I'm just going to show you very quickly where to find this on Google Classroom. I'll print it to you guys for tomorrow, but there isn't time now. If you go onto your Google Classroom, the N8 Maths class, if you go down to, here is an extra, no, that's actually not that one. Just check, did I post it? It looks familiar, hey, you guys, I haven't seen that before. I wonder where I saved it. Okay, I'll just post it again, guys. I'll post it now, so it's going to be the first thing on the screen. Okay, I'll post it for you now. You can start working on that for a few minutes. Don't click away, please. There's a couple minutes left. Start working on that now. I'm just going to post it quickly. Yeah.